Okay, this is my week 3 wrap-up video. As always, in a couple minutes, I'll switch over to my keyboard and go over a few things from the feedback in Knowledge Check 3. In general, people enjoyed the topic, enjoyed the discussion. Just a reminder, a couple people with the discussion posts did not post twice, so remember you get full credit if you post your response to the prompt, and then you also need to respond to someone else's post. So I think 2 people did not do that second step. So just a reminder to get that done when you're doing the discussions, okay? To summarize the discussion into some broad themes, I'm going to just refer to my notes here. Again, it was a really, really interesting discussion. So a bunch of you kind of talked about failures, examples of failures in data governance and in oversight. So some examples, Equifax had some broadly publicized credit score errors in 2022 due to a coding error. Someone had brought up issues with the UK Office of National Statistics and an issue with their governance and oversight that led to some problems there. So very interesting examples. A second broad category had to do with integration, right? And I've talked the last couple of weeks about the challenges of integration. So system integrations, legacy systems, technical errors. So someone had brought up issues in the merger of Charles Schwab and TD Ameritrade. Okay, and I'll tell you, whenever you've got 2 large companies merging, often there are issues with data integration. That was always a challenge when I worked at CVS. When we were acquiring other chains, I was at CVS during a couple acquisitions. And that was always a challenge for us from an operations perspective to get the other systems onto our system. And there was always kind of a period of time where you had to be extra vigilant because that's very challenging. Okay. Not just to get the systems together, but also to get the humans, right? The humans integrated. The humans, the employees get used to certain processes and procedures. And so that's challenging. Another example, Southwest Air, their crew member assignment database was outdated, caused a lot of problems. So that was another example. A third theme that came up had to do with human error, manual processing, coding mistakes, things like that. So a good example I liked there was from Uber. So Uber was calculating driver commissions on the full fare and not taking into account the fact that taxes had to be paid. So that led to miscalculation of driver commissions. And then the final theme had to do with AI, machine learning, large-scale automation, and all the data quality issues that arise from those types of systems. Some of which is due to just poor training data. Remember, garbage in, garbage out. So if you're training your models on low-quality data, you're going to get some results that are based on low-quality data. An example that came up there, Unity Technologies. They had corrupted machine learning models because some of their external data that they got was faulty. Okay, so that's a really important. And again, that's I always kind of use the example of the Jungle, the book The Jungle, and its expose of the meatpacking industry in the early 1900s. And I kind of think that similarly, we'd be horrified if we kind of thought through like some of the data that our machine learning models and algorithms are based on, right? I think people are getting more sophisticated with this, but there are plenty of examples out there of machine learning and AI gone wrong, right? And now, because so many systems rely on these things, the risk is actually higher. So that makes data quality so much more important. Anyway, very interesting discussion. Keep it up. I really enjoy reading your posts. So let me switch over to my keyboard, go over a couple things from the feedback, and then I'll see you on the other side. Okay, just a couple things came up in the feedback on Knowledge Check 3. First of all, in terms of the questions, in general, people did very well. And really the only question where I saw people losing points was this last question about the box plot. So I've already loaded the data set into Jupyter Hub. We need to make a box plot showing the distribution of age by profession. So this is an example where we want to compare a numeric variable versus a categorical variable. Age is a numeric variable, right? We've got our age variable, and then profession is a categorical variable. So if you look back to the hands-on videos for week 3, I think it's the very last set of videos where I go over basic visualizations. When comparing a numeric versus a categorical variable, I think the best way to visualize that is with a side-by-side box plot. Okay, so this would be a df.boxplot, and then the first parameter column equals, and you give it the name of the numeric variable, so that's going to be age, and then by equals, and for this one you give it the name of the categorical variable, profession. Okay, and here's our box plot. So now we can see this is the distribution of age for first responders versus medical professionals. Okay, and the question was asking roughly what are the median ages for each profession in the data. Okay, so in a box plot, the median is this green line. Okay, so certainly for medical, that's pretty straightforward. That's about around 35. Okay. In terms of first responder, we kind of have to do a little bit of estimating here. It's a little bit below 20. I'd say that's like 18 or 19. Let's see what our choices are here. And typically, I only gave you one choice that was kind of near there, right? So it would be 19. Okay, so that was the answer to that one. Okay, but the key is to recognize we're trying to visualize a numeric versus a categorical variable, therefore a box plot. Actually, I told you to make a box plot, so that I guess I made that a little bit more straightforward. But the median is the green line. If that wasn't clear, the green line in the middle of the box is the median, the halfway point. Okay. A couple other things that came up related to the coding. People enjoyed learning how to code in Python. A couple people mentioned that this is ramping up on the difficulty level, and that's true, right? We're now getting into a little bit deeper into data analytics. Someone had asked about what the right of order of the code is, or they were saying they were struggling with the order of the code. So typically, when I kind of profile my data, I first read it in, and then typically, it kind of doesn't matter, to be honest with you, what order you go in. But I always sort of look at, okay, where am I, what are my missing values? Okay, I've got two variables that are missing values. I then look at like data types to see how is my data being read in. And so if I kind of look at here, like vaccination date, that looks like dates, but it's being read in as an object. So I start getting a sense of if I've got an issue with the data types. I then look at my summary stats. So I use the describe command. Okay. And then I start summarizing some of these categorical variables with value counts. So, df profession dot value counts. Okay. And then I could look at like adverse reaction, df adverse reaction dot value counts. Okay, et cetera, okay? So again, the order in which I do these things actually don't matter because there's nothing I'm doing with any of this code that's changing the data. The only time the order really matters is if you're changing the data. So when we get to feature engineering, where we're actually going to change the data, order might matter because I might want to make a change that then affects a calculation, and therefore I need to make the change first before the calculation. So that's kind of where that would matter. But if I'm just simply kind of profiling the data and seeing what I have, there's nothing magical to say I have to kind of get the missing values, third, right, or second in the process. The key is just to kind of do all these different steps. That's the most important thing. You want to read in your data. You want to look at it, see how much data you've got. You want to get a sense of your missing values, how the data is being read in terms of data types, and then start summarizing the variables with numeric. The nice thing is we have one command that does it for all the numerics. For the categoricals, we have to kind of do it one at a time, right, with value counts. Okay, and then obviously we can do some visualization. That's also a good step. Because with like numeric variables, I can try to make a guess as to what I think this distribution looks like. So I look at this, I see the mean is 35.5, the median's 34. That's pretty close. Okay. I do see a huge jump between 75% and max. So if I had to guess, I think it's probably skewed a little bit to the right, to the high side. But I don't really know that, right, until I look at the histogram. So let's look at the histogram. Plot.hist. okay? And yeah, that kind of shows me, aha, yeah, I did have some outliers. So you can make some guesses here, but you really don't know unless you actually visualize the distribution. And by the way, when I'm looking here, I see I have at least one outlier, right? I see a jump from 38 to 89, but I have no sense of how many outliers. And it's by looking at the graph that I'm like, oh, okay, it's not just one outlier. I actually have a bunch of outliers out here. Okay, so visualizing the data is also always a really good idea. Um, Someone had kind of mentioned they're still struggling a little bit with whether to use square brackets versus parentheses, and all I could tell you is that right as of right now, there are two reasons to use square brackets. And actually, I'll add on a third because if you've been watching the videos for week 4, um, I've introduced a new command called loc, which locates. So one use of square brackets is if we're trying to get data from the data set. So what do I mean by that? If I want to look at a particular column, right? So here I'm kind of pulling out this column, this age column, okay? I use square brackets to do that, okay? That's similar to what I'm covering this week in the week 4 hands-on videos with this loc command. The loc command here, you're basically filtering your data. So here, let's say I only want to look at the rows where the age was less than 25, okay? And it pulls out just the rows where age is less than 35. But it's actually a similar concept, right? Here, the brackets are saying, give me the age column. And in this case, it's saying, give me the age column to compare it to 25. This is then saying, give me the rows that meet this criteria. So the square brackets for loc are really the same purpose as the square brackets when I'm just giving it a column. It's basically saying, go into the data set and locate and pull out a subset of the data for me. So that's one reason we would use square brackets. The other reason is if I have a list of things. So age, comma, adverse reaction, right? So if I want to get those two columns from the DF data frame, I have to give it a list of those two columns, okay? But then I also need to use square brackets to say, give me those columns. And let me actually use the square brackets. There we go. Okay, so again, the outside columns are saying, give me these columns. The inside brackets are saying, here's a list. So really, those are when you're going to use square brackets. Every other time, it's regular parentheses. Okay, so I know that, you know, at the beginning that's a little confusing, and trust me, it gets easier because I'm not going to be throwing a ton of new instances of using square brackets at you. So those kind of three reasons. I'm trying to access a column. I'm using the loc command to locate some rows, which means to pull out some rows. And then I'm also giving it a list of more than one element. That also uses square brackets. Every other instance, it's parentheses, okay, for the most part. One other thing that came up, someone had asked with the Python coding portion of the course, they just wanted a little clarification on how we're building on what you've already done in DA1 and DA2, other than just learning Python. And I'll tell you, at this point in the course, you're just learning this in Python. So I haven't built on what you're doing from DA1 at this point, because you need to know the basics, right? I can't launch you into like new things with analytics in coding if you don't know how to read your data set in and profile your data set. And one thing I'll tell you is, like, even if we think about DA1 versus DA3, a lot of the process to do an analysis with a data set is the same. It's always going to be the same. You read in your data, you first look at the data, which means profiling the data. You try to see if there are any issues with your data, or if you might want to create new features. That then leads you to feature engineering, which we'll get to in week 5, which is changing your data, fixing any errors, adding any features that might be useful. And then you start modeling. And when you build your models, you start interpreting, right? So, you know, that process, that's true regardless of what data analytics course you take, right? So DA1 covered that process. Well, guess what? We're covering that process as well. There's nothing different about that process. That's the fundamentals of reading in a data set and doing a little bit of analysis with some modeling, right? We're at the beginning stages, right? So I'm trying to teach you how to read in data, how to access data. This week, we're looking at how to filter your data. Next week, we'll look at how to change your data. Okay, and there might be a few things in feature engineering that are a little bit different. I will tell you later in the semester, particularly when we get to the modeling portion of the course, while I will be covering some of the models that you covered in DA1, I will also be covering models that you have not seen. So for instance, in inferential modeling, I cover the traditional linear regression. You've seen that before. I cover logistic regression, which I'm pretty sure you've seen before. But I also cover something called the Poisson regression, which I'm pretty sure you did not see in DA1, right? When it comes to machine learning, I cover a decision tree. I'm pretty sure you've seen that before. I cover a random forest, which you may have seen before. But I also cover something called support vector machine, which I'm pretty sure you have not seen before. Okay. When we get to like looking at our model performance, okay, we're going to look at ROC curves. Okay, we're going to look at the area under the curve. Okay, these are measures you might have touched a little bit on, but we're going to kind of cover that in a little bit more depth. I'll also cover something called the J statistic, which I'm pretty sure you would not have seen in DA1. And then finally, when it comes to visualization, I'm going to be covering how to create graphs using ggplot, which, by the way, is a function and a package that's native to R, but I'm pretty sure you would not have covered that in detail in DA1. We're going to cover that in detail. By the end of the course, you're going to be able to know how to create really nice, polished graphs using ggplot. And by the way, by learning ggplot in Python, because it's also native to R, guess what? You're also learning how to do it in R. The coding is very similar between R and Python when it comes to visualizing with ggplot. So that's at the end of the semester, okay? So I appreciate that there are some of you that are hungry to kind of get to some new stuff. We'll get there, but we're kind of at the beginning here, right? And so I can't just jump to a bunch of new stuff without at least getting into the fundamentals of how to read your data in and profile your data, okay? Hopefully that was helpful. Okay, welcome back. So hopefully you found that helpful. Just a couple reminders. So for this week, we're in week 4. We're looking at a bias, analytics bias. In terms of the Python material, we're looking at how to filter and sort your data. So filtering the data with the loc command, which is going to be really important when we get to feature engineering next week. This loc command is the command that's going to allow us to select certain rows to then change if we want to change the data, right? So that's why that loc command is so important. And then sort values is how we sort our data. In terms of what's due this upcoming Monday, Knowledge Check 4, Discussion Post 4, and then also the first of the graded assignments. So the profiling assignment, which is posted in, there's a Canvas assignment, but there's a notebook file that you're working with that's in your Jupyter Hub. It's called assignment_profiling, I think. You're going to fill out, you're going to answer all the questions in that notebook file. So you're going to have to write some code. Make sure for any question where it's asking for code, but it also has in brackets, type your answer here. That means that I've asked you a question and I want you to write sentences, right? So sometimes I will get submissions where someone has only given me Python code, but they didn't actually answer the questions, and you're going to lose points for that, right? So make sure in a question, if I'm actually asking you a question, not only do you need to have the code to get to the answer, but then you as an analyst then need to interpret your answer, right? Write a couple sentences, write a sentence to actually answer the question, okay? So just anywhere that I say type your answer here, that means I'm looking for sentences, right, in addition to code. So that's due Monday. I've also posted the next 2 things, which will be due the following Monday. So the coding project on profiling is posted. That's where you're getting your data set. Let me just check, actually, the following Monday. Yeah, so, right, so February 16th, just looking at the schedule. February 16th, the coding project profiling assignment is due. Where you're getting your own data set for your coding project and you're going through these profiling steps, just like you've been doing in this first assignment, okay? By the way, when it comes to your coding project for profiling, at this point, I'm not asking you to change your data in any way. I'm just asking you to tell me what you've got. So you may have messy data. You may have data that when you read it in, you're like, I need to change this. It's not being read in properly. That's the next step. But for this first assignment, You're just telling me what you've got right now. Okay, so the profiling assignment for the coding project, just tell me what you've got. Okay, and then I've also posted something called the connections exercise. There are two of these. The two connections exercises are really geared towards helping to think through how we code with AI tools. And so in this first connections exercise, I've given you some code that was generated by AI to profile data, and you'll see that the code is overly complex. And what I'm asking you to do is to identify ways that you can simplify that code based on what we've done in class. And then I actually want you to simplify the code. So I want you to take the code and edit it to make it a little bit more straightforward, a little simpler, because sometimes AI tools will give you code that's really, really complex when it's not necessary. Okay, so that's really what that extra. And then I'm asking you to kind of reflect on the process. So both of those things are due the following week on the 16th of February, but they are posted in Jupyter Hub, so you can get started on those as well. Also, just one last point for the coding project profiling assignment. If you chose to work in a project team, only one person from each team needs to submit. Okay, so only one submission per group. Yeah, obviously, if you're working individually, then you'll submit for yourself. But if you're in a group, only one person needs to submit. Okay, hopefully that was clear. Let me know if you have any questions, and I will see you next week. Bye-bye.